This is the last video in this series dealing with the conic section of ellipses, and in this video we'll be focusing on how to write the equation of an ellipse when given the location of some of its parts. So if we take a look at the first example, we are asked to write the equation of the ellipse that has endpoints of the major axis located at 10, 2 and negative 8, 2, and the foci are located at 6, 2 and negative 4, 2. So we have to create the equation of the ellipse. Now I'm going to write off to the side. Remember, the standard form for an ellipse is the quantity x minus h squared over a squared plus the quantity y minus k squared over b squared equals 1. And the reason why this is helpful is because it tells me I need to know my hk, which is my center. I need to know my a value, which is the distance from the center to the vertices on the horizontal axis. And I need to know my b value, the distance from the center to the vertices on the vertical axis. So what I'm going to do is I'm going to kind of sketch a little diagram to help me figure out all these parts. So I'm told that the endpoints of the major axis are located at 10, 2, and negative 8, 2. So if I were to think about just sketching a graph of it, we're at 10, 2, and negative 8, 2. At 10, 2, and I'll do this in blue for the major axis so we can see the vertices. Here's 10, here's 2. Like I said, I'm just sketching. So this is one of the vertices because it's an endpoint of the major axis. And so I'm all the way at negative 8, 2. Well, this tells me my major axis is horizontal. So it's a horizontal ellipse. And I need to think about, well, the major axis, the midpoint of it is the center. So the midpoint of the major axis is the center. And what that does is that allows me to get the HK values. Now, if you want, you can use your midpoint formula for it, or you can, if you have a good graph, actually count and figure out where the middle is between these. So I can do 10 plus negative 8, so 10 minus 8 divided by 2, and then, 2 plus 2 divided by 2. Well, 10 minus 8 is 2, 2 plus 2 is 4, so 2 divided by 2 is 1, and 4 divided by 2 is 2. So my center is located at the coordinate 1, 2. And that's helpful because it not only gives me my h and k, which allows me to right now write the numerators of our standard form. It would be x minus 1, that quantity squared. I still need to know what the a squared is on the bottom. And it's y minus 2, quantity squared. And I still need to know what b squared is on the bottom, 1. Well, not only does it give me my center and allow me to write the numerators in my standard form, but we also need to remember our definitions. The distance from the center to a vertex on the horizontal axis is a. So what's the distance from 1 to 10? Now here, I can just count. I mean, I know the distance from 1 to 10 is 9. So a equals 9. So I have a squared, which is 9 squared, which gives me 81. Now b is the distance from the center to the vertices on the vertical axis, but that's not what's given to me. What's given to me is the location of the foci. And the foci are on the major axis as well. Now here the foci are located at negative 4, 2, and at 6, 2. Now, since I use the right side for A, to make it easier visually, I'm going to use the left side. Well, the distance from the center to a foci, to a focus, is C units. So from 1 to -4, you go 1 to get to 0, and then 4 further, so that's 5. The reason why C helps me is because of our formula. We know that to find C, we do C squared equals the larger of the two, either A squared minus B squared or B squared minus A squared. And since this is a horizontal ellipse, I do A squared minus B squared. So C is 5, so I have 5 squared, which is 25. I know A squared is 81, so 25 equals 81 minus B squared. I'm going to add the B squared to put it on the left side to make it positive, and I'm going to subtract the 25 from the 81, and that's going to give me 56. So B squared, which I want, is 56. I don't need a square root or anything because the formula says x minus h squared over a squared plus y minus k squared over b squared. And so I get 56. And there is the equation of the ellipse. Now, the important part for this is to make sure you understand the definitions. And that's why in the previous videos I've been explaining you need to know the distance from the center to the vertices is A units on the horizontal axis, that it's B units on the vertical axis. The distance from the center to the foci is C units. Is if you can know that, not only do you not need to use the formulas to find those coordinates, but you can also write the equation of ellipse when you're given the parts. So let's look at example 2. The major axis is 16 units long, so that's an important piece of information for me. The major axis is 16 units. It's parallel to the x-axis. Well, if it's parallel to the x-axis, since the x-axis is the horizontal axis, this statement tells me it's a horizontal ellipse. The center is at 5, 4, so right away I can see this is my center, that's my h, and that's my k. So when I'm asked to write the equation of the ellipse, I know it's going to be the quantity x minus 5 squared over a squared, which I don't know, plus y minus 4 squared over b squared, which I don't know, equals 1. So I need to find a squared and b squared. I'm also given this piece of information. The minor axis is 9 units long. So how does this help us? Well, first off, I know it's a horizontal ellipse based off of the first sentence, which means that my larger number, or my major axis, my A, is going to be underneath the x minus h squared. But the major axes, if we were to think about a regular old ellipse, and I can sketch one for us, the major axis for a horizontal ellipse is the distance from vertex to vertex, for this example, on the horizontal. So if I take a look from the center, which we're told our center to vertex is A units. From the center to the other vertex is A units. So remember the major axis is actually the formula 2A, twice A. So if I know the major axis is 16 units, twice A is 16, which means A is 8. So then for the formula, I square A, 8 squared is 64. So I have the quantity x minus 5 squared over 64. The other piece of information that's given to me is the minor axis. And remember, the minor axis goes from vertex to vertex. Here, it's going to be based off of the vertical for it. And that distance is going to be from center to the vertex B units, and then the other direction is center to the vertex B units. So the formula for the minor axis is twice B. So if the minor axis is 9 units long, then 2B equals 9. B equals 9 halves. Yes, use the fraction. And then you square B. Well, 9 squared is 81. 2 squared is 4. And so I have here, underneath the quantity y minus 4 squared, 81 fourths. And that is my standard form for the ellipse, represented by a major axis 16 units long, parallel to the x-axis, a center at 5, 4, and a minor axis that is 9 units long. This is why it's important to understand what the value of A is, what the value of B is, what the value of C is, not just rely on the formulas, but understand the concepts behind the formulas.